Okay, so you want to know about this question? It's what, number 14
Yeah.
in 12.2?
Mm-hmm.
Okay, which says something like you have two vectors, right?
Yeah, two non-zero vectors that are not parallel or anti-parallel.
Okay, A and B, not non-zero and not parallel or anti-parallel.
And then you have to show algebraically that if C is any 2D vector, there's scalars S and T such that...
Oh, wait, these are 2D vectors.
Yeah.
Okay, so I have two 2D vectors that are not zero and are neither parallel nor anti-parallel.
Yeah. And then 15 they talk about 3D, but
Okay.
it's 2D.
And I have C that's some other vector.
Yeah, any other vector.
Okay, so any other 2D vector,
Mm-hmm.
C, right?
And then you're trying to prove that there are scalars S and T such that, and they have a formula, C
So I'm supposed to show that there exist S and T scalars
yeah, yeah,
with, let me guess, C is TA plus SB.
yeah. They switched them, but yeah. Same thing.
Yeah, sure, whatever. Okay, so what you need to do to show that there exists some scalars like this, is the first thing you want to do is like maybe try to find the scalars, which is going to be a little funny.
By using like actual vectors.
Yeah, so you kind of can't use actual vectors, right? Because it's supposed to be for any
Mm-hmm.
A and B that aren't zero and aren't parallel, right? Or anti-parallel.
What's anti-parallel? Is that just perpendicular or?
So, the way that I usually define parallel in the videos is this way. I say that V is parallel to some vector W, right? So I say V parallel to W means, right, really if V is some scalar times W.
Oh, okay.
And this book differentiates kind of this case and this case.
Okay.
I would say these two vectors are parallel.
Mm-hmm.
Your book chooses the more specific, they're anti-parallel.
Okay.
So in your book, they add this little V is parallel to W if V is KW and K is a number 0 to infinity.
Yeah, and not
And it's-
negative infinity.
Yeah, and V is anti-parallel to W if V is KW and K is some negative value
Mm-hmm.
and not 0.
That makes sense. I just never heard of that before.
Yeah, so I really would like, for both of these things to be called parallel, and this one to be like a specific subcase of parallel. This is not really quite standard notation.
Okay.
So like this isn't quite standardized. Usually what you mean by a vector being parallel to another is that it's a scalar multiple.
And because you can move them anywhere, it doesn't matter where the...
Yeah,
tail
exactly. It doesn't really matter whether it's, yeah, exactly. Okay, so to show this, I think what you want to do is you want to think to yourself, what if I had a couple vectors, right?
Mm-hmm.
So I'm going to just think about my vector A. I'm going to assume that's a, vector A1, A2,
Okay.
right? And B is going to be a vector B1, B2. And C is going to be some vector C1, comma C2.
I started there, but I used like X, Y, Z, W, U, V, and it just was...
Yeah, that gets terrible, right? So, like, decent notation is usually to just take the vector's name and number it for all the components, and that'll keep things a little bit easier. Because then you won't have to wonder, like, where did W come from?
Yeah.
Because
to look back at your key.
yeah, anything labeled W is going to be part of the vector W, right? right?
Mm-hmm. Okay.
Okay, so I'd start with this, and then I'd write down, I think, so if I kind of think about what this statement means,
Mm-hmm.
right, like, let me just try. Let me write this statement down. I'm not sure that I'm gonna be able to come up with a T and an S
Mm-hmm.
where this works, but I'm gonna try. So, I think if I look at the first components, right, that's gonna be C1 has to be T times A1 plus S times B1, right?
Yeah,
And then a similar thing's gonna be true for C2. What's C2 gonna be?
that would be T times A2 and S times B2.
Okay. And then you gotta bust out your algebra 2.
Mm-hmm.
So, I would recommend that you take this first thing and multiply by, say, A2, and then you take the second equation and multiply by minus A1.
Okay, yeah,
My goal here is to get rid of the, what am I trying to get rid of?
all of the, wait, 1 second. I multiplied by like negative B and A, but then that's a whole vector, so I'm just trying to,
Yeah, you don't wanna do that.
yeah, so
So,
here you're
if-
trying to get rid of the B's?
so what am I
Not
trying to
quite.
establish exists here?
That those scalars exist, so,
Yeah, I wanna establish that T and S exist, right?
yeah,
So the first thing I'm gonna do is try to find one of them. I picked S just cuz. So if I wanna find S, I need to get rid of the T's. See that?
okay,
So if I multiply through by these guys, I'm gonna get A2C1 is T A2A1 plus SB1A2, right?
yeah,
And then on the other one, I'm gonna get minus A1C2 is minus TA2A1.
oh, and you add,
Uh-huh. Oops, and not plus, but minus SB2A1.
I always forget that you can add equations together.
And then
like
I'm gonna
that.
take these two equations and
Makes a lot of
add.
sense, okay.
Right? So once I add these two equations, I got A2C1 minus A1C2 is SB1A2 minus SB2A1. And then how do you solve for S?
You pull it out of there,
Good, you need a factor, right? So you got A2C1 minus A1C2 equals S times all of B1A2 minus B2A1.
and then you divide it out.
Okay, and that's the trick, right there. You divide it out, right? So you get S is this gook with A's and C's divided by this gook with B's and A's, right?
Yeah,
Okay, but you can't always divide,
why?
right? This step
Oh, because
here,
it's, that's like its own unit with the,
yeah, so this step
minus.
here you multiplied by 1 over B1A2 minus B2A1. But there's a number you can't divide by.
0,
Yeah, you can't divide by 0, right?
and then,
So this only worked,
oh, when it's non-zero.
right? So I found, not quite,
Or
so
one of
that
the
would be
components
the-
could be 0?
yeah, some of the components could be 0, but this whole thing can't be 0.
Mhm.
Right, so I can find S provided that B1A2 minus B2A1 isn't 0.
Yeah,
Right,
oh, then you
so,
just have to prove that.
A2 B1 minus B2 A1 isn't 0. Right? If you go through and fiddle with this same thing with T, you'll find the exact same thing.
Okay,
So you'll figure out that you can find S and T, provided that this thing isn't 0.
because you
And-
just switch the multiplication at the top and then get a different formula and
Yeah,
pull out T.
yeah, just chase that out, you'll get the exact same
Okay,
thing. The answer will be slightly different, right, because it'll have B's in it instead of A's in it or something, but it'll be basically the same idea. This condition will certainly be the same, the thing you need to divide by will be the same. So, what does this guy mean? Well, if you apply a little algebra to what it would mean, like when is it broken, right, so
oh,
you switch your thinking from when is it okay to when is it broken. So it's broken when A2, B1 equals B2, A1, right?
Yeah.
Okay, and then you think to yourself, all right, if A and B aren't 0, right,
But one of the components.
then one of the components in one of them isn't 0. It maybe would be easiest to like look at this thing and think to yourself, that really may as well be A2 divided by A1 equals B2 divided by B1.
Okay.
I'm saying think this because, well, in order to do this, I'd have to be sure that A1 and B1 aren't 0,
Yeah.
right? Because I divided through by those. So you might spend a minute arguing about if one of them were 0, what would happen to the other vector, and like.
But at this point, A1 versus A2 doesn't really matter, so you just put whichever one.
Yeah,
isn't
you could
0
divide
for
through by whichever one isn't 0. You need to ensure in your head that you're allowed to divide by both A1 and B1, right?
Okay.
So there's a
but
little
then
there's a
if,
little
like-
argument to make here
Okay.
that I'm skipping. But the important thing is when you see these guys, you should really be thinking about the slope.
Oh, okay.
A2
Makes
over
a lot of
A1
sense.
is the slope of the vector A. And B2 over B1 is the slope of the vector V, right? B. If these two are the same,
Then they're parallel.
then they're parallel,
Oh, that makes
right?
a lot of sense.
So I can
Yeah.
find S and T as long as they're not parallel.
Okay. And then that's approved.
Yeah, and so the non-zero part of that takes a little doing, right? Because really it's not quite if they're not, like, I glossed a little bit by thinking this. You gotta go through and fiddle with, okay, well, what if one of them has a 0 in it? What does that say about the other one, and how does that work? But I think you can do that. That should be pretty easy
Okay.
reasoning. Cool.
That makes sense.
The gist of this, right, is you have a vector A that looks something like this. You have a vector B that looks something like this. If you have another vector that looks like, say, this guy. What this says is that you can always get to this by doing some A's and some B's.
Which
So,
makes sense.
like in this guy, I might have to back up a few A's, right? I might like, okay, I'm gonna back up 1, 2, 3 A's, and then it looks like I need to go up a couple of B's.
Okay, yeah.
So my new vector here, V, right, might be about minus 3A plus 2B.
What's up with the thing on the top of the B? Oh, that's a vector thing.
Yeah, that's,
It's like, that's a cool way to draw a B. Okay,
Cool?
cool. Yeah, that makes a lot of sense.
Okay.